All right, so now that we have discussed discrete uniform distribution under a discrete random variable, we now talk about another type of discrete distribution, which is basically binomial distribution. So a binomial distribution is any type of distribution in which there are two possible outcomes, and one outcome is often viewed as success while the other is actually a failure. So you either have success or you have failure. So these are basically the two types of outcomes you have. So in many investment contexts, we might view outcomes either as a success or a failure, or a binary, which means two outcomes in one way or the other. So binomial distribution, actually the random variable for the binomial distribution is called Bernoulli random variable. So Bernoulli random variable, meaning it's a variable that can take on two possible outcomes, one of the two possible outcomes, and one is a success and another is a failure. A simple example of a binomial distribution could be that of a coin toss. So when we toss the coin, this can be considered as a one trial. And when we toss the coin, we have two outcomes only. One is a head and the other is a tail. And we can consider head as success and tail as failure. So Bernoulli random variable will be the outcome on the coin toss. And each time we toss the coin, the toss will be considered as a trial, and it's called Bernoulli trial. Okay, so it's called Bernoulli trial. All right, so let's look at a general example before we discuss the binomial distribution in more detail. So let us say that we have a coin and that we will actually toss. So the probability, as we know, of head, and head for us is labeled as success, as we know, is 50%. If the probability of one outcome is 50%, then the probability of the second outcome, which is tail, will of course be 1 minus the probability of head, which is 0.5, is equal to again 50%, right? So the probability of head and tail would be in this way. So the probability of head on any toss is 50%, and so is the probability of tail on any toss also 50%. Now, the question is, if I toss the coin once, what is the probability of head? And the answer is 50%. If I toss the coin the second time, meaning the second trial, what will be the probability of head again? What are the chances of head happening? Again, it's 50%, meaning on every toss or every trial, the probability stays constant. So here we look at the assumptions we are actually writing. The first assumption that we are discussing is that probabilities stay constant across trials. So your probabilities remain constant. So in the first trial, the probability of head is 50%. And so the probability of head on the second trial again is 50%, and so on. Across tosses or across trials. Secondly, if I toss the coin once, the probability of head is 50%. And if I toss the coin again, the probability of head is 50%. Do you think the first toss can in any way affect the chances of getting an outcome on the second toss? So if you get a head on the first toss, do you think that can affect the chances of getting head again on the second toss? No. Each toss is independent. Each trial is independent, and hence they will not affect each other. So the second assumption is that each trial is independent of the other. All right, so far we have looked at the assumptions, and we have looked, we are discussing a binomial distribution. So in that distribution, every time there is a trial, you only have two outcomes. We have written here the probability of the one outcome, which is success, and the probability of the failure as well. And we spoke about the two key assumptions, which you need to remember for the exam as well. And let's say you want to toss the coin 10 times. So that means the number of trials that you have, the number of tosses or the number of trials that you have are 10. You want to toss the coin 10 times. And what we are looking for is actually the probability of getting 4 heads in 10 tosses. So here's what we are looking for. The first question that we are looking to answer, that's our first question. probability of getting 4 heads, this is our success, in 10 trials or in 10 tosses. So the total number of trials are 10, and what we are looking for are 4 heads. In other words, out of 10 outcomes, how many number of successes, how many number of heads are you looking for? You're looking for 4 heads. If you will get 4 heads out of 10 tosses, the remaining 6 would of course be the failure, which is the tail. So the number NT represents the tail. So the number of tails that you expect to get are actually 6. So what is the probability of getting 4 heads in 10 trials? So NH is 4 and NT is 6. What I could do is better write this right here. So the number of heads we are looking for are 4, and number of tail would of course be then 6, while the total tosses are 10. Now, how can we answer this? If you think about it, this is more, you can have the first 4 outcomes as heads, you can have the next 4 outcomes as heads, you can have the center 4 outcomes as heads, you can have the last 4 outcomes as heads, meaning there are so many ways in which you can have 4 heads out of 10 tosses. And if you recall from the previous reading, this is actually, we are referring to the combination rule, which is the number of ways you can get R outcomes out of a total of N outcomes. So that's more like saying the number of ways we can get 4 out of 10 out of a total of 10 tosses. So we will say NCR. We will use the combination rule to get the number of ways, and we'll multiply that by the probability of success. In this case, the probability of success, as you see, is 50%. So the probability, I'll write it this way. This is the probability of success. But we're not looking for 1 success. We're looking for 4. So that means we'll multiply probability of head 4 times. So probability of head times probability of head times probability of head. Or alternatively, we will just say probability of head to the power of 4, which is the number of heads. All right, times the probability of tail to the power of number of tails. So here's in simple what we are saying. We'll use the combination rule, right? We'll look for, we'll say 10 second NCR4, right? That's what we will say. Times the probability of head to the power of number of heads times the probability of tail to the power of number of tails. And this will give us the probability of getting exactly 4 heads in 10 trials. Let's plug in the numbers. Here is how it will be. You will say, first of all, how do you put the combination rule in the calculator? You will say 10 second NCR4. So let me do that, 10 second NCR4, and the answer is 210. So in 210 ways, you can get 4 heads out of 10 tosses. What is the probability of heads? We know that's 0.5. And how many heads are we looking for? We said we are looking for 4 times. What is the probability of tail, which is also 50%? It will not necessarily always be equal. And the number of tails we are looking for is simply 6. So let us try and see what is the answer we actually get. And the answer we get is 20.5%. So the probability of getting 4 heads out of 10 trials or 10 tosses is around 20.5%. All right, let's jump to the next question related to this, which is question 2. Let's go back to our scenario. We have the probability of head, or the probability of success in each trial is 50% and the tail is 50%. The number of trials we have are 10, okay? What are the expected number of? What is the expected number of successes? What I mean by the successes is heads. So how many heads are you expecting? So if you have 10 trials and the probability of getting a success or the head is 50%, then you will just say n times the probability of success, which is head. We label the head as success, and that will give us the expected number of successes. If you recall, whenever you want to find the expected value, you just weigh the outcomes by the probability, right? So if you have 10 outcomes and the probability of getting the probability of getting a success is 50%, which means the probability of hit is 50%, that means you're expecting 5 successes. The expected number of successes are 5 out of 10 trials. Okay, another related question. Find variance and deviation. We know variance cannot be interpreted given the fact that it's actually squared. So how do we get the variance? The variance can actually be calculated as variance is movement away from the expected value of 5. So the way it's basically calculated is we say n, which is the number of outcomes. We weigh it by the probability of both outcomes times the probability of success, which is head, times the probability of failure, which is tail. And let's see what answer we get. This will give us the variance. So the variance is around 10 times 0.5 times 0.5, and the answer is 2.5. This is the variance, while we need the deviation. So how do we get the deviation? This is our variance. The deviation will be the 2.5 square root, and that gives us 1.58. That means on average you're expecting 5 successes, but it could deviate by around 1.58. So related to binomial distribution, you could expect 4 types of questions. Number 1, you should be able to calculate as we saw here, the probability of getting 4 heads out of 10 trials. You should be able to calculate the expected number of successes or heads. You should be able to get the variance and deviation. You should know the assumptions well. You should know what does a Bernoulli trial mean and a Bernoulli random variable. All right, given all this, I would also like to add something here, which is actually that we could look at a different version of a similar question. What you saw here was probability of getting 4 heads in 10 trials. There could be a question that might be like probability of getting 4 or lower heads in 10 trials. So what is different here is we're saying or lower. It could be or higher as well. Now, what are we going to do? Look, we got the probability of getting exactly 4 in 10. So we will have to repeat the same function that you see here, the same expression, multiple times. So we will first do, we will say NCR. We'll say the probability of getting 4 out of 10. So we'll say 10 second NCR 4 times the probability of head to the power of number of heads. How many heads are we looking for? We are looking for 4 heads times the probability of tail to the power of 6. And then we'll repeat again. We will say NCR, we'll say 10 second NCR 3. So we want to find the probability of getting exactly 3. Probability of head to the power of 3 times probability of tail to the power of 7. Because out of 10 trials, if you have 3 heads, you will have the remaining 7 as tail. You'll repeat the same again for 10 second NCR2, the probability of getting exactly 2, probability of head to the power of 2 number of heads times the probability of tail to the power of 8, because out of 10 you will have 8. And then you repeat this until you get to 0. And probability of tail to the power of 9. And finally, when you do for 0, that's when we will stop. And you will add all these up, because we're saying probability of getting 4 or lower. So you will add all of them up. And that will actually give you the answer. So you need to pay attention to, are they asking you to find exactly the probability of 4 successes, or is it 4 or lower? It could also be 4 or higher. Then you'll have to keep going up. You'll say 4 and 6, then 5 and 5, and then 6 and 4, and so on. right? So that's how you will actually do it. Now I'd like to look at this example. So basically, it's cut short. You work in equities trading at an institutional money manager that regularly trades with several block brokers. You classify each trade as an unprofitable or profitable. You have summarized the performance of the brokers in a spreadsheet in table 2 for November of last year. You've been given table 2, and there are two brokers here, broker BB001 and BB002, and the trades for both the brokers have actually been classified as profitable or losing. So we don't need to worry about how that has actually been done. But if you pay attention to the broker BB001, the total number of trades are actually 3 plus 9, which amounts to around 12 trades, and 5 plus 3, which amounts to around 8 trades, right? So the total number of trades that have been executed through the second broker are around 8. So if you view each trade as a Bernoulli trial, which means each trade is either a success, so you might label it as profitable, or it could be classified as a failure, which is losing trade. So view each trade as a Bernoulli trial, calculate the percentage of profitable trades with the two block brokers. Well, so we want to find what percentage of trades are profitable, right? Well, if you notice, 3 out of 12 are profitable. So this should be pretty straightforward. You just have to simply divide. So with profitable trades with 001 are 3 out of 12, and that amounts to around 25%. While the profitable trades with 002 are 5 out of 8, a total of 8, and that amounts to around 62.5%, which is fairly high. The percentage of profitable trades executed through the second broker are much or significantly higher than the broker 1. All right, a related example. So you now want to evaluate the performance of the block brokers in example 3, which was the previous example. You begin with 2 questions. If you are paying a fair price on average in your trades with a broker, what should the probability of a profitable trade? So in that case, what should be the profitability of a profitable trade? Now, notice one thing. If the trades are on average, if you're paying a fair price on average in your trades with the broker, then the chances of it being fair should be 50-50%. So if the price you traded at is fair, then most likely 50% of your trades should be profitable, and 50% of your trades should be not profitable or loss making. So that should be the answer, that if the trading happens at a fair prices, then 50% should be profitable on average, and 50% would actually be loss making. Now, a related question is, did each broker meet or miss that expectation? So to answer this, if we assume that it's 50-50%, the first broker, yes, did miss because it's significantly lower than the 50%, while the second broker did exceed the expectation, right? So if this was our expectation that it will be 50% will be profitable and 50% will be loss making, then the second broker did exceed the expectation significantly. All right, now let's jump to the third question. You also realize that the broker's performance has to be evaluated in the light of the sample size. And for that, you need to use binomial probability function. You thus address the following, referring to the data in example 3. Under the assumption that the prices of the trades were fair, calculate the probability of 3 or fewer profitable trades with broker BB001. Because we are making the assumption that the prices of trades were fair, therefore the probabilities that we will use will be the ones that we discussed in the first question. So we would assume that the probability that the trade would be profitable, the P is for profitable, is 50%. And the probability that it will be a loss making is also therefore 50%. If we go back to the previous example, the number of total trades as a sample that we had were actually 12. So the N in this case would be 12. And we want to find the probability of 3 or fewer profitable trades. When we say 3 or fewer, if you recall, we want to find the probability of 3, right? So 3 or fewer would be the probability of 3 plus the probability of 2 plus the probability of 1 plus the probability of getting exactly 0. And this could be considered as F3, cumulative probability. So first we need to use the expression to get the probability of exactly getting 3. And the way we do that is we are going to say NCR, which would actually be 12-second NCR 3 times the probability of the profitable trade. And the probability of the profitable trade, as we know, is 50% to the power of number of profitable trades you're looking for are 3 times the probability of loss-making trades to the power of number of loss-making trades out of 12. You're looking for 3 profitable, which means 9 loss-making. And then we repeat the same. We say NCR, we say 12-second NCR 2 times 0.5 to the power of 10. Again, we repeat. 0.5 to the power of 1 times 0.5 to the power of 11 plus NCR 0, 12 times 0.5 to the power of 0 times 0.5 to the power of 12. And if you add all this up, and I'm sure you can use the calculator to get your combination, the number of ways using the combination rule. So if you add all these up, you get around 7.3%. Right? So that's the answer you would actually get.